This is Mrs. Gilbert. Let's look at trapezoids and kites. Trapezoid is a quadrilateral that has exactly one pair of parallel sides, and those are called bases. The red arrows in the figure indicate parallel lines. Those are my bases, and the other two are legs. A trapezoid also has two pairs of base angles. If I look at the bottom of the figure, I have a base that connects angles A and angle D. And at the top, I have another pair of base angles, angle B and C, which are connected by a base. I don't have to have bases that are horizontal. They can be vertical or have some other orientation. Is this figure a trapezoid? If I take a look at slopes, I can determine if I have parallel lines. If I have exactly one pair of parallel lines, then I would have a trapezoid. RS and OT appear to be parallel. If I use slope formula, change in y over change in x, we can find that both of those slopes are 1/2. We do have a pair of parallel lines. The other two segments do not appear to be parallel, and if you check the slopes, you will indeed find that RO has an undefined slope, ST has a negative slope. Those are not parallel. We do have one pair of parallel lines. We do have a trapezoid. An isosceles trapezoid has two legs of equal length and base angles that are congruent. Take a look at the tick marks to see which parts are congruent. In order to find the angles, one of the first things I notice is that I have two sides that are equal. That means that the base angles must be equal. So I will find angle L first, and there are a couple of methods I can use to find angle J and angle M. Recall from earlier this year that if you have parallel lines in a transversal, the consecutive interior angles add up to 180. Write an equation, solve for angle J, and then I know that angle J and M have to be equal because they are base angles in an isosceles trapezoid. Another method I could use would be the one where I start with the four angles in a quadrilateral, and they add up to 360. I can write an equation here, and because J and M are equal, I can simply use 2J to represent both of them. Solve, and we get 130 for both of those angles. If a trapezoid is isosceles, the diagonals would be congruent. I have tick marks to indicate isosceles trapezoid, and that means that BD will be congruent to AC. A midsegment connects the midpoints of the legs. It's parallel to the bases. I know that I have midpoints because of the tick marks on this side, and I know I have another midpoint here because of these tick marks. In order to find the length of the midsegment, add the two bases together and then take half of that sum. Half of 40 is 20 inches. A kite is a quadrilateral that has two pairs of consecutive sides that are congruent. I have a pair here, and on the right I have another pair that are congruent. The opposite sides are not congruent. In a kite, you also have diagonals that are perpendicular, therefore you have a right angle between the diagonals. In order to find the side lengths of P and T, I can use the fact that a kite has perpendicular diagonals, and once I have that right angle between them, I know I can use Pythagorean theorem to find the missing parts. Let's start with the upper left triangle here. And subbing in the 3 and the 4 for A and B, subbing in P for my C, I have Pythagorean theorem, 3 squared plus 4 squared equals P squared. Use algebra to solve, and 5 is P. I also could have used a Pythagorean triple here, a 3, 4, 5 triangle. On the bottom left-hand triangle, I have 3 squared plus t squared equals 9 squared. Then t squared plus 9 is 81. Subtract the 9, I have t squared equals 72. And to solve for t, I'll take the square root of both sides. The square root of 72 is square root of 36 times square root of 2, which simplifies to 6 square root 2. A kite has exactly one pair of opposite angles congruent. Notice that the angle is between two sides that are not congruent. And in this kite, angle A and C are congruent, but B and D are not congruent. In order to find the measure of angle G, first I will find the measure of angle F. That would be equal to the angle across from it, so that's 110 degrees. I know that all four angles add up to 360, so I can write this equation and then use algebra to solve for the measure of angle G.